So in this video, I'm going to quickly run through the exam questions at the end of 6.1. The first one should be straightforward. They've drawn the dot and cross for you. You can see around nitrogen you've got 3 bond pairs and 1 lone pair. You need to learn that that's pyramidal, and you need to learn that the angle is 107, meaning the answer is B. The next one, they've told you that something has 2 bond pairs and 2 lone pairs. The shape is then going to be nonlinear and 104.5, so that's just a matter of knowing your shapes and your angles. The next one was the shape of COCl2. Carbon is your central atom. Carbon has got 3 bonding regions surrounding it, so you count the double bond as 1 bonding region. If it's got 3 bonding regions, the shape is going to be trigonal planar. The next one's a little bit trickier. Okay, they've label 4 atoms for you and ask which atom is a trigonal planar arrangement. So I've drawn that molecule again, except out in full. Around the first carbon, you can see you've got 1, 2, 3, 4 bond pairs. 4 bond pairs means it is going to be tetrahedral, so it's not atom 1. Atom 2 also has 1, 2, 3, 4 bond pairs. 4 bond pairs is tetrahedral, so it's not atom 2. Atom number 3 has got 1, 2, 3 regions of electron density. You count a double bond as just 1 bonding region. 3 bonding regions is trigonal planar. So I'm thinking that the answer is going to be C for atom 3, but I'm also going to check atom 4. So initially when I count, I've got 1, 2, 3 bond pairs. I might also be thinking that 4 is trigonal planar, but what I haven't drawn in is the nitrogen lone pair. Remember, nitrogen is in group 5. It's got 5 bonding electrons. 5 outer shell electrons. At the moment, only 3 of those electrons are accounted for because it's only forming 3 bonds. That must mean the remaining 2 electrons sit on nitrogen as a lone pair. So there's 3 bond pairs, but there's also a lone pair that's not shown. That makes it pyramidal. With all of your carbon atoms, carbon has only got 4 outer electrons, and each carbon atom has got 4 bonds. So even here with the double bond, you've still got 1, 2, 3, 4 bonds. Because all of carbon's outer shell electrons are involved in bonds, there is no lone pair. So what you see is what you get with carbon, whereas nitrogen, you'd have to remember to draw that lone pair. So your atom is going to be C, atom 3. The next one, you just asked to draw a dot and cross diagram. Again, just make sure you're including all of your lone pairs. You can see that you've got a double bond between carbon and oxygen, so make sure you've got 4 electrons between carbon and oxygen, and then a single bond between carbon and each chlorine. Oxygen is in group 6, it's got 6 electrons in total. 2 electrons are involved in bonding, but it's got 4 electrons as lone pairs. Chlorine is in group 7, 7 outer electrons. 1 electron is involved in bonding, 6 electrons are not, so it has got 6 electrons or 3 lone pairs. The shape of the molecule, and explain why it's got the shape. So I'm looking at the central atom, which is carbon, and there's 1, 2, 3 regions of bonding, 3 bonding regions around carbon. Again, that double bond just counts as 1 bonding region, so that's 1, 2, 3 bonding regions. That makes it trigonal planar, and your explanation will be 3 bonding regions, electron pairs repel. The next one, and I appreciate that's a bit tricky because we haven't really looked at alkyl groups yet, it's something we look at later, but it asks you for the carbon atom, the shape and bond angle around a carbon atom in the alkyl group. So I've labelled the 3 carbon atoms in the molecule. Carbon 1 and carbon 2 are in an alkyl group, carbon 3 is not. But again, that's something we'll look at further down the line. But now that we've identified that carbon 1 and 2 are the alkyl group, we can see what the shape and bond angle is. So it doesn't matter which of those carbons you look at, they each have 4 bond pairs. Because they've got 4 bond pairs, the shape is tetrahedral, the bond angle is 109.5. My explanation would be 4 bond pairs, electron pairs repel. There's no lone pairs around a carbon atom, it's only got 4 outer shell electrons, and it uses all of them to bond. Suggest a value for the COH bond angle in propanoic acid. So there's your oxygen. Okay, you can see that there are 2 bonds surrounding oxygen, but I know that oxygen's in group 6. It's got 6 electrons in its outer shell. Only 2 of them are being shown at the moment, which means it must have another 4 electrons present as lone pairs. 2 bond pairs, 2 lone pairs. The shape is non-linear. and the angle is 104.5. So 104.5 will be your answer there. The next one's actually the same question. The shape around the oxygen atom is non-linear, and they wanted to know the angle. So they told you it's not linear because, again, if I drew that out in full, I've got a carbon bonded to an oxygen bonded to a hydrogen. There are two bond pairs, but what's not shown is the two lone pairs on oxygen. Again, those lone pairs are present. Oxygen's in group 6. It's got 6 electrons. It's only using 2 of them in bonds. The other 4 sit on oxygen in lone pairs. So 2 bond pairs, 2 lone pairs. The bond angle is 104.5. And again, your explanation is going to be 2 bond pairs, 2 lone pairs. So you say the electrons around the central atom, and then you say electron pairs repel, and lone pairs repel more than bond pairs. If you actually look at all the mark scheme for all of these, they're really particular about what they will and won't accept. So you have to talk about the electron pairs repelling, but you can't talk about electrons repelling. It has to be electron pairs repelling. You also can't say atoms repel. It's specifically the electrons. Here in the next one, you'll see the same thing. You have to say that you've got 4 bond pairs and those pairs repel. If you didn't specify that they were bond pairs, if you just said electron pairs, you wouldn't get the mark because one of those could have been a lone pair. So you have to specify that they're bond pairs and then say that those electron pairs repel. If you said 4 areas of electron charge repel, you don't get the mark for that either. So really specific language that they want you to use. Here again, 2 bond pairs, 2 lone pairs. The lone pairs repel more than bond pairs do. Ignore just saying bonds repel, ignore electrons repel, do not allow atoms repel. So really specific language that you have to use, and the examiner's comments here are saying that it was poorly answered because they're not able to communicate using the correct language. So just make sure you are clear on what is required. You would say the number of electron pairs, specifying if they're bond pairs or lone pairs, and you have to say electron pairs repel. So 2 bond pairs, 2 lone pairs, electron pairs repel, lone pairs repel more than bond pairs. That's how you would answer that. In your last question, they ask you for the shape and the angle around nitrogen in 2 different molecules. You've got NH4 plus, NH4 minus. Now we're typically used to seeing nitrogen with just 3 bonds. And it's got 3 hydrogen bonds, and this is ammonia. So nitrogen's in group 5, it's got 5 electrons in its outer shell, and it usually uses 3 of those electrons for bonding, and then it has the remaining 2 electrons as a lone pair. So that's what ammonia looks like. The first one, they're telling you that you've actually got 4 hydrogens attached. 1, 2, 3, 4. Now, nitrogen cannot form 4 covalent bonds. If it did, you would end up with 2, 4, 6, 8 electrons, plus it would have its own unbonded electron, because nitrogen itself has 5 electrons. So it would use 4 for bonding and would have 1 left over. That would give it 9 electrons in total, and it would leave it with 1 unbonded electron, and you can't have a single unbonded electron. So what is actually happening here is you've got a dative covalent bond. You've got 3 of those bonds are dot cross, and the final bond is actually dot dot. So to form NH4 plus, nitrogen uses its lone pair of electrons to form a bond with a H plus ion. This means I've got 1, 2, 3, 4 bonds around nitrogen, but I'm only drawing 5 dots, 3 crosses, meaning 8 electrons in the outer shell, and the reason there's a positive charge is because nitrogen is effectively losing an electron to hydrogen by contributing both electrons to that covalent bond. But you're not asked about that, you're just asked about the shape. So when I draw it with 4 bonds, there's 4 bonds around it. 4 bond pairs means it's tetrahedral, and the tetrahedral bond angle is 109.5. In NH2 minus, I've only got 2 bonds to hydrogen. Now normally, if I only had 2 bonds, I would have 1 electron sitting on nitrogen by itself, because nitrogen has 5 electrons in its outer shell. But that minus charge tells me it has gained an electron, so I'm going to use an open circle to show that extra electron. It has gained an electron, so now my unbonded electrons are all in pairs, which is totally fine. And if I look around my central atom, I've got 2 bond pairs, I've got 2 lone pairs. That makes the shape non-linear, and the bond angle is 104.5. If you need help with drawing those electron shell diagrams, those dot and cross diagrams, particularly the ones that include dative covalent bonds, then go back and watch the other video that I made where I go through that in a lot more detail.